Hi, welcome. So far we've talked about the disk method for finding the volume of a solid of revolution, but not all shapes are going to use disks to find their volume, and so sometimes we're going to have washers. So this is just a modification of the disk method, where we take a hole in the middle of our disk to make a washer, and I'm going to talk about that now to give you the formula for that and show you when we use it. So all this takes is a simple modification of our disk rule, or disk method. And the goal here is that we can find the volumes of solids that have holes in the middle or that are hollow, holes in the middle or that are hollow. So instead of just a disk, like we've had before, so instead of this, what we're going to do is take that disk and put a hole in the middle and look at a washer. So this is like the washer you would use if you were doing some mechanical, building something. That's like a washer, like I don't even know what to call it. The little piece of metal that you use when you're doing stuff. Not my best explanation ever, but hopefully you understand what a washer is. It's like a donut. Okay, so we're going to use washers. So we use these washers specifically when we have shapes that have a hole in the middle, so we don't want full disks that we're adding up for the volume. We want to take out some volume in the center to represent just the outside bits. So let me show you an example of what this might look like. I'm just going to draw some arbitrary looking shapes to talk about. These can be all sorts of different things, but I'll show you one that pretty clearly requires washers. So let's say we have a function g, and maybe then a top function f. And so we just have this little itty bitty shape here. And we're going to look from A to B. So let's say we want to take this shape and revolve it around the x-axis. So what do we get? What happens? So when we do this, we're sort of drawing out a shape with this little itty bitty shape. You can think about drawing out a ring of sorts. So as this goes around, and let me try to draw it here next to it. What we have is we have this outer layer that's sort of creating this shape going down. So it's meeting up with another similar looking shape at the bottom. And then we'd have an inner ring that comes from the lower part. That one went really well, okay? And then it would meet up with this bottom bit. So we have this shape and it's sort of revolving around and it's drawing out the outsides of this ring. And so if we want to try to find the volume of this, we can't use disks because each of the little layers isn't a disk. It has this big empty part in the middle. So we're going to need washers in order to add this up. And so the goal is that and I guess not the goal, but our plan and how we're going to do this is that we will take the volume of the disk and then subtract out the hole. So if we found the area of this full disk and we sort of filled it in, wow, that is really bad. So we can imagine finding the area of this whole disk, then we're just going to subtract off the middle disk. So, and these are volumes, I keep saying area. We take the full area, then we take off the center area so that we're just left with the washer space. So let me draw this again just to maybe make it a little clearer. So if we're looking at the disk straight on, we're going to take this full disk. This is going to have our first radius, and then we're going to subtract off a center bit. So a smaller circle in the middle, we're going to subtract that off. And I didn't do a great job here. We're going to subtract off then this smaller radius. Okay. So this is what our washer is going to look like. We're going to take the big volume and then subtract off the smaller volume so that we're just left with the volume of the washer that we wanted. Okay, so in this example, the R1 is the outside radius, and that's our function on the outside. So that's our f of x. And we call this the outside radius, just because it's sort of on the outside of the volume of the shape we've made. Then we have our inside radius, which is going to be our g of x function. Okay, and so our plan is that we're going to find the volume of the full disk, and then we're going to subtract off the volume of the hole that we're removing from the shape to make the washer. So for the volume of the disk, we'd use the outside radius, so it's pi times the outside radius squared dx. This looks like our disk method. And then we're going to subtract off the inside disk, or the volume of the hole, and this is pi times the inside function squared times dx. So we've taken the full volume, subtracted off the hole in the middle to get rid of it, and so we're left with an equation for the volume of our washer. So we do pi times the outside radius squared dx minus pi times the inside radius squared dx. And these are the washers that we're going to add up to find the volume of the solid of revolution. So let me write out the formulas. These really build off of disk method. Remember, we're just modifying it to do something slightly different. And the modification is that we're taking out some of the volume that we don't want. So it's almost like we have a shape, but then we're like taking out a middle chunk of it. And so we get rid of that with the subtraction of this second volume. Okay, so our version where we revolve around the x-axis uses x as the variable. And so we do pi times, I'm going to factor that pi out since it's in both of these. And so then I just have left over f of x squared minus g of x squared, and then my dx is at the end. And so this is my formula for the washer method for a volume revolved around the x-axis. So let's write that out. This is the washer method for revolving around the x-axis. And then similarly, we'll have one that looks so similar for y. So instead, we just go from y equals a to y equals b. And we just have f of y squared and f of g squared. Oh, sorry, g of y squared. So it looks very, very similar. Everything is just in terms of y here. And we use this one when we are revolving around the y-axis. So this is the washer method for y-axis. Okay, so this is the washer method. It's very similar to the disk method. We just take off that area with the subtraction of the inside radius squared, and we will try this out on an example in the next video. Thanks so much for watching, and I will talk to you in the next one.